Example 2.4.3b. Determine the line and phase currents in the balanced delta connected generator shown in figure 12 if IAB is 15 at angle negative 20 degrees amps. Draw a phasor diagram of the currents. Assume balanced operation. So the given for this problem statement is first that we have a delta connected generator. So let's go ahead and draw that delta connected generator. Again, it's three phase, so we have three different sources here, and they are connected together in this triangle shape, also called a delta configuration. Notice there are three common terminals here. We'll label this terminal A, this terminal B, and this terminal C. Therefore, we have a voltage as measured from here to here. We call that VAB. We have a voltage measured from here to here. We call that VBC. And we have a voltage measured from here to here. We call it VCA. I'll rewrite that for clarity. VCA. So those are the voltages we have on a balanced three-phase delta generator. And there are some terminal connections for the three-phase system. We've got I in line A, we've got I in line B, and we've got I in line C. We notice that the current here has to be the sum of those two currents here, which means the current here is not equal to the current here. So this is IBC. The current flowing in that direction is IAB, and the current flowing in that direction is ICA. So in summary, for this delta configuration, this delta generator, there are only three voltages, but there are six currents, three line currents and three phase currents. The last part of the given statement was that IAB is equal to 15 at angle negative 20 degrees amps. You can notice I've indicated IAB is right here. This is the phase current associated with the AB phase of the delta source. We are asked to find I phase and I line to complete the delta circuit here. So the solution to that is, since we were given this, the IAB quantity, that's the reference quantity, it's real easy to solve for the other phase currents because the phase currents all need to be 120 degrees out of phase. So we'll just write that IAB is equal to 15 at angle negative 20 degrees amps. IBC is going to be IAB times 1 at angle negative 120. And so that's just going to give me 15 at an angle negative 140. And then ICA is going to be equal to IAB times 1 angle 120. So that's 15 at an angle 100 degrees amps. So the phase currents are all 120 degrees out of phase with one another. So 120 degrees phase shift there, 120 degrees phase shift there, 120 degrees phase shift between those. Next, we are asked to find the line currents, and we know that in a three-phase delta source, the line currents are equal to the phase currents times root 3, and they lag by 30 degrees. So we multiply by negative 30. So IA is going to be equal to IAB times root 3 angle negative 30 degrees. And that's going to be 15 at an angle of negative 20 amps times root 3 at angle negative 30. And so that's going to give me 25.98 at an angle negative 50 degrees amps. IB is going to be equal to IBC times root 3 at angle negative 30. and that's going to be equal to 15 at angle negative 140 times root 3 at angle negative 30, so 25.98 angle negative 170 degrees amps. And then IC is going to be equal to ICA times root 3 angle negative 30 degrees, so it's going to be equal to 15 angle 100 times root 3 angle negative 30. That gives me 25.98 amps at an angle of 70 degrees amps. So those are the currents there, and we were asked to draw a phasor diagram of those. And we'll take 15 angle negative 20, that's IAB. We notice that the other two currents are 120 degrees out of phase with that. That's angle 140 is, let's see, that's 90, that's 180. Let's see, 140 is about right there. That's going to be IC. Oh, nope, sorry, that's not right. That's 100 degrees is what's in that quadrant right there. So 100 degrees is roughly right there. That looks better. So that's ICA. Sorry about that. IBC is negative 140, so that's this quadrant right here. So that's 120 degrees there, 120 degrees there, 120 degrees there. IA lags IAB by 30 degrees, so that's going to put IA down here. It's also larger in magnitude than IAB, so that's 30 degrees. IB lags IBC by 30 degrees, so that's IB, that's 30 degrees there. And IC lags ICA by 30 degrees, so that's 100 minus 30, so that's 70 degrees right there, so that's about right there. So that's IC. So gives you some idea of the phase relationship of the currents in the delta system.